give it would be the blueprint ng material na gagamitin. Ito yung pagkakilala ng material na gagamitin. So that is the resistivity of the material. So last meeting, I also discussed our resistance wherein R can be equal to rho L over A, letting that L, which is our length, and A as our cross-sectional area where the current will pass through. Okay, so also na-discuss ko rin that these parameters are helping or making or can be used in order to let the resistance let the resistance become higher or lower, or pwede natin i-control yung resistance through length and area or outside parameters. Okay, yung length at area natin. Kasi yung raw natin, yun na yung inside parameter natin, which is yung material na gagamitin natin or yung choice of materials natin. Okay, so sa exam, kailangan nyo ring malaman kailangan nyo basahin yung PowerPoint kasi hindi puro problem solving yung exam natin. And of course, sinasabi ko na dati, you must master your integral and differential calculus. Okay? And also your mathematics. So, as I have said, your rho of resistance or in R is equal to rho L over A. Adong bright ng screen ko. Napakasakit ko sa mata. Check. So, yung resistance natin or in R is equal to rho L over A. The inside parameter is our rho, wherein it is the resistivity of the material. So, kahit anong material na gamitin mo, yun yung rho niya. So, kahit anong pagpihit mo sa length at area niya, hindi na magbabago yung rho niya. Because yung rho is already the material itself. So, pag gumamit ka ng gold, gamitin mo yung rho ng gold. Pag gumamit ka ng copper, gamitin mo yung rho ng copper. And of course, the resistance that you would need in the circuit will depend on the length and area na lang. Kung sakaling gusto mo pang ibahin yung resistance niya. Okay? So, ito yung mga discuss natin last meeting bago nag-brown out mo. And of course, na-discuss ko rin yung Ohm's law natin, wherein Ohm's law, ito yung isa sa pinaka-importanteng law sa electrical engineering, wherein it is V is equal to IR. So yun lang yun. V is equal to IR. Voltage is equal to current multiplied by resistance. Take note that Ohm's law is only applicable for those linear materials or linear elements. Okay? But it is not applicable to non-linear like yung diodes. Kaya sa diodes, gumagamit tayo ng tinatawag nating voltages. Huwag kayo mag-alala kasi hindi naman tayo mag-solve ng diodes. That is for electronics engineering students. So, pag CE at EE, more on resistance lang tayo. Okay? Here. So, also, I have discussed the difference between open circuit and short circuit. Pag sinabi nating short circuit, we have an infinite current and we have a zero resistance. Meaning, pag infinite yung current natin, masyadong mataas yung current natin, mataas yung temperature, and it would lead to sinasabi nating electrical fire. Pag open circuit naman, ito yung ginagamit natin if we are opening or we are switching off any of the devices that needs the current. So pag tinanggal mo yung resistance, ibig sabihin walang dadaluyan yung current. So therefore, current is zero. Meaning pag current yung zero, R is infinity. Okay? So yan. Puro ka na lang, no? Mabilis ang sabi na lang kasi nasabi naman na. So review na lang. So, important considerations when you are solving circuit elements is that the power dissipated in a resistor is a nonlinear function of either current or voltage. Nonlinear siya because particularly a current and voltage, pag sinasabi kasi nating mga parameters there is that normally it is going sinusoidally. Okay? But indirect current, nagkakaroon tayo ng tinatawag nating constant. Okay? Constant yung ating graph. Okay. Of course, since R and G are positive quantities, the power dissipated in a resistor is always positive. Okay, it is always positive. As I have said last meeting, ang resistor natin, siya lang yung tagatanggap. So he would only absorb power, but it would never generate or give energy to the circuit. Okay? Also, nasingit ko rin that G or yung conductance natin, stability of the material to let the current to pass. So siya yung kabaliktaran ng ating resistor, which is, it is inversely proportional to our resistance. So therefore, I may say that G is equal to 1 over R. Okay? So pag mataas yung G mo, ibig sabihin, mababa yung resistance mo. Pag mataas yung resistance mo, ibig sabihin mababa yung G mo or yung conductance mo. Basically, they are in inverse relationship. Okay? Para nagmamadali Nagmamadali talaga ako guys. No? Kasi meron pa tayong 9 examples na matapos natin. Next. So dito, diniscuss din natin about the equivalent resistance. So basic connections lang tayo. And also basic properties. So as I have said last meeting, pag series resistor, we are always saying that our I total, so yung current total natin, is equal to the current entering to our resistor 1 and also equal to the current entering to our resistor 2. Or pag nilagyan mo pa ng resistor 3, it is always equal to the current entering to our resistor 3. That is a characteristic of a series connection. Also, a characteristic of a series connection is that voltage is additive. So yung V total natin, which means it is the source, the voltage in the source, ito yun, is always equal to our voltage of our resistor 1 plus the voltage of our resistor 2. Pero pag linagyan mo pa ng resistor 3 and so on and so forth, it is plus V3 plus V4 and so on and so forth hanggang sa Vn. That is additive. Also, I have derived our formula for our equation or the equation of resistance in series connection. So, paano po natin ginawa yun? Using this term. Yung ating V total is equal to V1 plus V2 plus V3 plus Vn. So, analyzing it using yung tinatawag nating Ohm's law, which was discussed a while ago. Ohm's law, which is V equals IR or R over VI or I over V over R or R over VI. So, yun yung Ohm's law natin. So, take note that V is equal to IR. So, from here, pwede kong sabihin that my V total is equal to my I total plus multiplied by my R total, wherein this R total is the resistance of all the series connection in the circuit. So from here, I have my I total multiplied by R total as my V total. So dito yan. Ito. Okay? So titignan natin ha. V total is equal to I total multiplied by R total. And also, I have my voltage 1. Okay? So take note that my voltage 1 was, syempre, I1 multiplied by my R1. So whatever current that is entering to my resistance is will be equal to the voltage that is in my resistance or in my element in that specific magnitude of current. Okay? So from that, I will have a value equal to I1 R1. Of course, for my V1. Plus, yung pumapasok sa current sa resistor 2 ko, which is equal to I2. Which is equal to I2 multiplied by my R2. Siyempre, of course, it is equal to my V2. So, pag may V3 ako, siyempre mag-add ka pa ng I3 plus I3 multiplied by V3 and so on and so forth. Now, since we know that the property of a series resistance or resistors that are introduced a while ago is that I total or the current that is entering all throughout the resistor is equal to the current entering to any of the resistor at series connection. So, take note at series connection, lahat ng current natin ay equal. Okay? So, from that, I will have this value. So, since I1 is equal to I2 is equal to I3, which is also equal to my I total, so therefore, dito mapapansin nyo, since I1 is equal to I2, which is also equal to my I3, kung merong R3 or I3, and of course, meron tayong I total, so gagawin natin yan, substitute natin siya dito sa values natin ng ating VIR. Okay? So, from that, you would realize that I total multiplied by R1 plus I total multiplied by R2, which is equal to my I total multiplied by my R total, right, can be rewritten as this one. Pwede nating ilabas yung ating I total. So, factoring out my I total by mathematical laws, so therefore, R1 plus R2 matitira, which is equal to my R total. So, take note that R total is also equal to my R equation. So, this is the derivation for this formula. Yan. Next, we have our parallel resistor. So, if you would compare a parallel and a series resistor, the characteristic of a parallel resistor that would be needed in everything that you are connecting, especially sa houses nyo naka-parallel connections yan, is that it's constant voltage. Okay? So, mapapansin nyo, sir, di ba, ba't hindi tayo gumagamit ng series sa bahay? So, as you go on with the understandings that pag series kasi may mga voltage drop tayo. 230 volts lang yung source ng bahay, di ba? So, ano yung pinakamagandang gawin? Di ba? Lahat ng mga appliance natin nasa 230 volts. So, pag siniris ko yung connection ng mga ilaw at appliance ko, so ibig sabihin, iwaksin natin yung safety. Ibig sabihin, theoretically, pagdating sa pinaka-load na kailangan ko is that hindi na siya 230, di ba? Kasi nga mataas yung voltage drop ng series resistor kasi nga yung additive is yung voltage at yung current naman yung equal. So therefore, ang tendency doon is that hindi niya kayang supplyan yung voltahe na kailangan ng appliance nyo. That's why, ang ginagamit sa mga bahay is yung tinatawag nating parallel resistors or parallel connection, I should say. So, pag parallel connection kasi, ang pinaka characteristic nito is that yung total voltage is equal to any voltage of the connected element in the circuit. Okay? Iulit ko. Pag parallel resistor, we have V1 equals V2 equals V total equals V3, which is equal to Vn. Lahat ng nakakabit dyan has equal voltage. Okay? So, ang additive naman is yung tinatawag nating current. So, take note, ang tawag natin dito, sa mga points na to, itong isahan dito, is yung tinatawag nating node. Yung node, ito yung interconnection ng different branch circuit. Okay? Yung branch circuit, you would know it more in the finals kasi nga, later on, you would be having a plan on, you will have electrical plan. Pero syempre, wala kayong lab, puro computation lang. Okay? So from here, meron tayong node. Itong node natin is the connection of all branches in the circuit. So, ito ang tandaan nyo na lang. So, para maraming sabi. Pagpapasok sa node, this is going into the node is positive. Okay? So, mapapansin nyo, this is I total. And pag lumabas sa node, going out of the node is negative. Which is equal to, sige, less muna, less I1, less I2, which is equal to 0 because of what you call the conservation of charge. Kaya, lagi kong sinasabi that current in a parallel connection is additive because we have I total is equal to my I1 plus my I2. So, pag dinagyan mo pa ng isa dyan, we already have our plus I3, plus I4, plus I5, and so on and so forth. So let's focus in these two resistor muna. So we have our I1 plus my I2. So how will we derive this formula? Just like on how we derive our series connection formula by the property of the connection alone. So ngayon, I total is equal to I1 plus I2. So dito muna tayo sa dalawang resistor para hindi kayo mahirapan. I total is equal to my I1 plus my I2. Right? So going back sa law natin, it is our Ohm's law, which as I have said is the most important because with this, you can derive anything in electrical terms. So V is equal to my IR. So from that manner, I may say that my I total, this one, my V total multiplied by my, V total is equal to my I total multiplied by my R total. So katulad lang din ang ginawa natin kanina. So V total is equal to my I total multiplied by my R total. Yan. So take note then that my I1 or my V1 is also equal to my R1 multiplied by my I1. Kung ano yung current na pumasok sa resistor ko. And then with my R2, so my V2 will be equal to R2 multiplied by my I2. Now, from this, I can have the value of my I. Wherein, based on Ohm's law, our I is equal to V over R. Right? So from that, so pwede natin sabihin that I is equal to V over R. So I1 is equal to V1 over R1, and also my V2 is equal to my my I2, I should say, ito, is equal to my V2 over my R2, and of course, yung total current natin, so my I total is equal to my V total all over my R total. Okay, so from the sense of it, let us substitute the values into our equation. So from that, meron tayong value na, so V total all over my R total, which is equal to my V1 all over my R1, plus my V2 all over my R2. So ngayon, let's go back sa sinasabi nating property na lagi kong inuulit-ulit kanina. The property of a parallel resistor is that all of its voltage from its total voltage to its V1, V2, V3, and V4, and so on and so forth, basta nakaparallel yan, it is equal. Okay? So therefore, from that, I will have V total or over my R total is equal to my V1 all over my R1 plus V2 all over my R2 since equal to, so therefore VT is equal to VT all over R1 plus VT all over R2, which is equal to VT all over R total. So from that, pwede kong i-factor out yung VT ko. So therefore, I will have a value equal to 1 over R total multiplied by VT. So VT multiplied by 1 all over R1 plus 1 all over R2. So pwede natin cancel to. So therefore, I will have a value equal to 1 over R total is equal to 1 over R1 plus 1 over R2. Okay? Wait lang. Pause ko lang muna. Tanggal. Okay guys, so medyo mas mali na siguro yan. So yan. So R total is equal to 1 over R1 all over 1 over R2. So yan. So this is the derivation of our formula. So pag gusto mo pang damihan, syempre magdadagdag ka pa ng B. So plus 1 over R3 and so on and so forth dyan. Okay. So paano ba natin yung gagawin sa calculator? So ang gagawin natin dito is that yan. R total is equal to 1 all over 1 over R1 plus 1 over R2 plus 1 over R3. Okay? So, paano ba nangyari yun? So, parang ganito lang. Magka-cross multiply ka. Itong R1 mo, R total mo, mag-divide by 1 ka dito. So, ganyan. 1 divided by 1 over R total is equal to 1 all over 1 over R1 plus 1 over R2 plus 1 over R3. Itong R total mo, syempre tataas yan, di ba? Kasi dinivide mo eh. So therefore, R total is equal to, matitira yung ating nasa baba, 1 over R1 plus 1 over R2 plus 1 over R3. Sir, paano pag parehas yung R1, R2 at R3 ko? So how about if R1 is equal to R2 is equal to R3 at may parallel? Ang mangyayari niyan, ang maging formula mo is that, so ganito. So R total is equal to, ito no, so pare-parehas, so we have 1 all over 1 over R1 plus 1 over R1 plus 1 over R1. Ang mangyayari yan is that R total is equal to 1 all over, pare-parehas yung denominator mo. Mathematically, it is equal to 1 plus 1 plus 1 all over R1. So therefore, R total is equal to R1 all over 3. So, di nyo mapapansin is that pag kinukuha mo yung resistance ng parallel, lumiliit at lumiliit siya. So, hindi tataas ang resistance ng isang parallel connection sa pinakamababang resistor. You have a parallel connection of 5 ohms, di ba? So, pag nakaparallel lang 5, 5, 5, which is equal to my R total. Pag kinuha mo yung R total yan, is that is always equal to 5 over 3. Okay? 5 over 3 yan. Kasi nga, nakuha naman natin dito, di ba? So, at similar resistor, R total is equal to, parallel connection ha, R X all over L. So, papatunayan ko sa inyo na 5/3 dyan. So, gamitin natin yung calculator natin. X yan. AC. So, 1 all over. Naglagay tayo, syempre. 1 all over 1 over 5 plus 1 over 5 plus 1 over 5. Okay? Is equal to 0.667 or equal to 5/3. So, yung sinabi ko kanina na hindi bababa sa pinakamababang resistor yung value ng resistor natin. Or, I mean, hindi siya tataas doon. Let's say, yung pinakamababang resistor natin is 2. Mapapansin mo ganyan yan, 10 over 9. Hindi siya tataas ng 2. Okay? Nasa 1.1. Pero pag yung pinakamababang resistor mo, let's say, nasa 1, hindi siya tataas ng 1. Okay? So, yan. Yun ang property ng isang parallel resistance. Sobrang bababa at bababa yung resistance mo, which will not exceed the smallest value of the parallel resistance to it. So, yan. So, mga patalastas lang kumbaga. But I would discuss more about this connection as we go on with sa midterm natin. So, kasi magdadagdag na ako doon ng tinatawag nating series parallel connection. Okay? So, yan lang yung isipin nyo. Pag series resistor, property, equal yung current, additive yung voltage. Pag parallel resistor, equal yung voltage, additive yung current. Yung formula ng series resistor is that R equation is equal to R1 plus R2 plus RT and so on and so forth. Pag parallel resistor naman is that R equation is equal to 1 all over 1 over R1 plus 1 over R2 plus 1 over R3. So ito yan. Para hindi kayo mahirapang magsulat sa calculator nyo. Okay? Kasi pag ito yung gagamitin nyo, ikuha nyo pa ulit yan. I-divide nyo pa ulit ng 1. Okay? So, medyo matagal. Okay? So, let's have our conceptual problem. So, if you have any question, just feel free to chat or raise your hand, no? Para malinawan. Okay? yung mga iniisip nyo. So let's have our conceptual problem. Mga conceptual problem natin, syempre yung mga sobrang madadali lang, no? Problem 1, an electric iron draws 2 ampere at 120 volts. Find its resistance. Okay. So in this problem, V, gamitin lang natin yung ating V is equal to I, R. Okay? So ang tinatanong is, find its resistance. So our V is equal to 120 volts. Our I was initiated as 2 ampere. So therefore, I may say that 120 volts, substitute natin yung value dito, which is equal to my I, which is equal to 2 ampere multiplied by my R. So therefore, I will have a value of my R, which is equal to 60 volts per ampere, or it is equal to 60 ohms. So yan. Napakadali lang. Next, the essential component of a toaster is an electrical element which is called a resistor. So, pag umiinit talaga, pinaka-kailangan or essential element is yung tinatawag nating resistor. Pag maglalab kami later on, kung gusto nyo malaman, siyempre kung gusto, pwede kayong tawagin, no? Pinapausok namin ang resistor. Okay? So, a resistor that converts electrical energy to heat energy. Note, a resistor will never make power. Hindi siya magbibigay. Ang gagawin niya lang, mag-absorb at gagamit. Okay? Next, how much current is thrown to by a toaster with a resistance 10 ohms at 110 volts. Okay. So, V is equal to IR ulit. Yung V natin is equal to 110 volts. Yung I natin is equal to unknown. Ito yung tinatanong, how much current. And then, of course, yung R natin is equal to 10 ohms. Okay, so unknown to. Baka mamaya magkama lang to. So, ngayon, gamitin natin yung V is equal to IR. We have V, which is equal to 110 volts, which is equal to my I, multiplied by my R, which is equal to 10. So therefore, we'll have a value equal to I equals 110 over 10. So calculator. Gamitin natin ng calculator yan. We have 110 over 10, which is equal to 11 ampere. So sumunod kayo sa pag-calculator natin, no, para pag may maling na calculator, at least may ma-respond kayo sir para malito. Okay? Next. For the circuit, as shown, calculate the voltage, conductance, power. Voltage, conductance, power. Sa our voltage, ano ba yung mga given? Our given is I, which is equal to 2 milliampere. So yung I natin is a current source. Next, V, unknown. And then our R, which is equal to 10 kilo ohm. Passive sign convention of power. Positive direction, pumasok sa positive value ng ating voltage. So therefore, we have a value of our voltage which is equal to IR. So positive yan. So from that, I will have a value equal to 2 milliampere multiplied by my 10 kilo ohm. So 10 kilo ohm is 10 raised to positive 3. Milli is 10 raised to negative 3. So makakancel lang yan kasi negative 1 plus positive 1 is 10 raised to 0, which is equal to 1. So therefore, I will have a value equal to 20 volts. Okay, that is my voltage. Okay. Next, yung ating conductance. So, conductance G, as I have said, is equal to 1 over R. So, we'll have a value equal to 1 all over 10 kilo ohm. So, 1 all over 10 kilo ohm, nasa kwanto? 10 multiplied by 10 raised to positive 3. So, meron tayong value ng 100 micro. 100 times 10 raised to negative 6. So 100 micro-Siemens for my G. Or, pwede rin pag hindi kayo aware, pwede kasi isulat to as 100 micro mo. 100 micro mo. This is also our G. Okay? Next, for our power. So take note that yung sinabi kanina, resistor will always receive power. So pag sinabi nating receive, it is always positive. So therefore, our power is equal to VI. Wherein, positive 10 kilo ohm kasi pumasok sa positive value ng ating positive value ng ating resistance. Okay. Resistance. So therefore, yung meron sa atin is isang resistance at isang current, walang voltahe. But this was solved as 20 volts. So gawin ko, V is equal to my IR. So therefore, from that, I will have a value equal to my I squared multiplied by my R. Okay? So I squared is equal to 2 milliampere. So 2 times 10 raised to negative 3 squared multiplied by my R, which is equal to 10 kilo ohm. Okay? Or 10 times 10 raised to 3. So from that, so calculator lang natin, we have 2 multiplied by 10 raised to negative 3. So yan. Okay? So squared multiplied by my 10 kilo ohm. 10 times 10 raised to positive 3. Okay? So we have 0.04 or we have 40 milliwatts. That is my power. Okay? So ganun lang ating Ohm's law. V equals IR, V equals IR, or P is equal to VI, and then gamitin natin yung Ohm's law. And then of course, yung G natin or yung conductance natin is always equal to 1 over R. Okay? Next. So problem number 2. So a bar of silicon is 4 centimeter long with circular cross section. If the resistance of the bar is at room temperature, what is the cross-sectional radius of the bar? Okay, so ito yung problem na nakalimutan ko maglagay ng resistance. So pag ganito, magtanong kayo sa akin kung may error yung problem. So if the resistance of the bar is at room temperature, so therefore, let's say is 5 ohms na lang para pare-parehas kayo ng ibang set. Is 5 ohms at room temperature, what is the cross-sectional radius of the bar? So ngayon, ang application nito sa real life is that yung iiba-iba natin yung resistance niya through our length and yung tinatawag nating cross-sectional radius or yung cross-sectional area. So from here, ang kinukuha is yung cross-sectional radius. So ano ba yung formula natin for this? We have our R is equal to rho L over area. So ano yung meron tayo? Our R is equal to 5 ohms, which was I initiated. And then, yung length ng ating bar, which is equal to, L is equal to 4 centimeter multiplied by my 1 meter over 100 centimeter. Tama? So from here, I will have a value equal to 4 over 100. So 0.04 meters. Okay? Next. Ang tinatanong is yung cross-sectional radius natin, which is nasa cross-sectional area natin, which is equal to, syempre, pi r square. Okay? Area ng circle multiplied by length, yung volume. And then, ito yung unknown. And then, of course, yung rho natin. Yung material na ginamit natin is yung silicon. So therefore, paano ba natin kukunin yung silicon? Nandito siya. Ito, resistivity of the material. Take note that resistivity is ohmmeter. So pag gumamit ka ng ibang table, ang isipin nyo, ang lagi nyong tignan is yung ng resistivity, yung unit ng resistivity. Kasi once na naging ohm feet yan, tapos meter, naka-SI yung mga ginagamit mo, wala na, di ba? Paalam. Sayang 1 point. So from here, I will have a value of my silicon, which is equal to 6.4 times 10 multiplied by positive 2. Okay? Ayan. So 6.4 multiplied by 10 raised to 2. Dito tayo. Balik tayo sa baba. (6.4) multiplied by 10 raised to 2. So ngayon, meron na lahat. Recto formula, walang kahirap-hirap, di ba? So 5 is equal to, okay, 5 ohm is equal to 6.4 multiplied by 10 raised to 2 ohm meter multiplied by my length, which is equal to 0.04 meter divided by my area, which is equal to pi r square, since kailangan yung radius. So from here, we can cancel out our unit, our ohm. So therefore, R square is equal to 6.4 multiplied by 10 raised to 2 multiplied by 0.04. Siyempre, meter square na to, kasi meter multiplied by meter all over my pi. So getting the square root of this one. And then, of course, is getting the square root of our R. So I will have a value of my R equal to, gamitan ko lang yung calculator, square root divided by 6.4 multiplied by 10 raised to 2. So multiplied by 0.04 all over my shift pi. Okay? 6.4 multiplied by 10 multiplied by 0.04 centimeter. Siyempre, multiplied by yung 5 ohms ko. So, yan. Hindi ko nalagay. So, from that, I will have a value equal to 1.2766 meters. Okay? So, pag kinuha natin yung unit niyan, is nasa, so okay na to. Okay, accept ko na to. Or, it is at 1,277 millimeter. Okay? So, pag nasa LMS kayo, 1,277 millimeter. Siyempre, depende rin kung anong gusto kong unit. Pag naka-micrometer, ganyan. But since nasa pwede namang i-millimeter, so ganito na lang. Para hindi kayo mahirapang mag-point pa, tapos mamaya magkamali pa kayo sa point, so sayang yung puntos. Okay? There. Next. We have our problem number 2. Okay, recall ko lang yung naging solution, no? Para sa mga hindi nakaneg. R is equal to rho L over A lang yung ginawa natin dito. So after R is equal to rho L over A, so tinignan natin kung ano yung tinatanong, which is yung cross-sectional radius. And then tinignan natin kung ano yung meron na pwede natin gamitin para ma-solve yung ating problem. So take note that yung rho natin, kinuha natin sa table. So, sir, paano pag may table ako, tapos merong binigay sa problem, anong gagamitin ko? Suggestion yung binigay sa problem. Okay? Kasi yun yung requirement ng area na yun. Okay? Or yun yung requirement ng environment na yun. Okay? So, yan. Next. Problem number 3. So, ma-circuit tayo. So, take note that it is composed of passive and active element. So yung passive natin, of course, yung ating absorb. Yung absorb lang na-absorb, which is yung resistor. Tapos yung ating active element is a voltage source. Independent voltage source ang tawag sa mga circle na yan. Okay. So, para ba natin solve to? I-apply natin dito yung concept ng short circuit at open circuit. So, in this term, our at position 1, which is which the problem one is to calculate first is yung switch natin is nasa position 1. Ibig sabihin, kinos natin to, yung current ngayon dadaan dito. Okay? So, yung current natin dadaan dito. And then, dyan pumapasok yung tinatawag nating open circuit. So, open circuit to, ibig sabihin, at position 1, dito ko, at position 1, ay at 150 ohms is equal to 0. So, walang current na dumadaloy dito kasi nga it is open, di ba? I is equal to 0. Tapos, yung I naman na papunta dito, linus natin, papunta siya dito. So, therefore, I 100 ohm at position 1, meaning yung switch natin is nandito. Okay? So, therefore, I will have a value equal to V equals my IR. Wherein, so take note papapansin nyo, yung 15 volts natin, pag gumawa ko ng loop dito, yung KVL, no? Yung current natin, pumasok sa negative, no? Pumasok sa negative. So, therefore, I will have negative 15 multiplied by the positive direction of my current. Okay? Tapos yung current natin, papasok sa dito sa ating 100 ohm. Okay? So, yan, voltage pala to, so huwag natin ilagay yung I. So, negative 15, and then pumasok siya dito sa ating 100 ohm. So, as I have said, a resistor is always positive. Di ba? Nag-absorb. So, therefore, I will have plus 100 multiplied by my I. So, saan galing yan? Take note, this is voltage, which is equal to my IR. Sinapply natin yung voltages natin dyan. Conservation of energy, kumbaga. So, equals 0. So, therefore, 100I is equal to my 15 volts. So, therefore, I is equal to 15 all over 100, which is equal to 15 all over 100. Meron tayong value ng 150 milliampere. Okay? Then, that is at position 1. Okay, position 1. So, para naman pag position 2 tayo. Draw ko na lang. Ito yung position 2 natin. So, positive, negative. We have our 15 volts. Ayaw mag... Teka, ganda. Trophy ko na lang na ganito. Okay. So, ito yung ating 100 ohm. Tapos, ito yung ating position 1. Kanina. Ngayon, sa position 2, yung ating I naman is papunta dito. Okay. So, ito yung position 2 natin. So, therefore, from that, our switch will be here. Will be moved here. Based on the statement of the problem. So according to the problem, find the current when the switch is in position 2. So this is our position 2. So therefore, from that concept again, our I here is equal to 0 from the concept of our open circuit. So ngayon, dito naman yung ating 15 ohms. Yung I naman natin dito, syempre, papunta dito. Okay, sa pataas. So pag nag-loop ulit tayo, passive sign convention natin, but by voltage or yung tinatawag nating conservation of energy. So take note na yung I natin pupunta sa 150 ohm. And as I have said, ang I is always an absorber. So it is always positive. So 150 resistor, I should say. So 150 multiplied by I, less yung voltage natin. Less 15 volts equals 0. So therefore, from here, I will have a value equal to my 15 volts is equal to 150 ohm I, okay, ohm multiplied by my I. So therefore, I will have a value equal to my I, which is equal to 15 volts all over 150 ohm, which is equal to 15 all over my 150 is equal to, syempre, 100 milliampere. Ganun lang kasimple yan. Wait, pag gumagamit kayo ng KVL o yung tinatawag nating passive sign convention, na positive yung current, ganyan, see to it na pag voltage yung ginagamit nyo, voltage lang yung nasa equation. Pag power naman, power lang yung nasa equation. Eh, hindi kasi additive ang voltage at power. Hindi rin additive ang current at voltage. Ang additive lang is that yung voltage to voltage and current to current, and of course, power to power. Okay? So, yan. So, recap ko lang yung ginawa natin. In-apply natin yung open circuit voltage. We're in at first position, nandito yung position ng switch natin. Okay? Meaning, naka-close to, tapos ito naman ay naka-open. Okay? So, from that, in-apply natin yung V is equal to IR, yun yung pinakasimple na lang, para hindi kayo malito, V is equal to IR, wherein my V is equal to 15, kasi nga naka-parallel to sa 100 ohm. Parehas lang yung voltahe ng dalawang yan. Okay? Or in more deeper concept is that gumamit tayo ng tinatawag nating KVL, Kirchhoff's voltage law, which is based on tinatawag nating conservation of energy. But in its lower concept, yung 15 volts natin, nakaparallel sa 100 ohm natin, so therefore nag-V is equal to IR na lang ako, which is equal to 15 equals 100 multiplied by my I, which is parehas lang siya dito. Ganun lang din sa yung ginawa natin dito sa ating solution B. The only difference is that yung position ng ating switch, which is from position 1, ilinagay natin siya sa position 2. Ayun, at position 2, yung I natin dito will be equal to 0 kasi nga wala nang current na dumadaan, wala nang current na dadaanan kasi nga butas. So, 0 siya. Dito naman, meron tayong 15 volts. So, ito yung nagkaroon tayo ng current na may full path, closed path, yan. So, therefore, nagkaroon tayo ng value which is equal to 100 milliampere. So, as I have said in yung lower concept nito is that V is equal to IR lang. Kasi nga, yung 15 volts natin nakaparallel dito. So, therefore, pwede kong sabihin that I will have a value equal to 15 equals I multiplied by the resistance, 150. So, therefore, I is equal to 100 milliampere. Yan. So, yan kasi, nakukuha mo na lang yung concept dyan as you go deeper the subject. Yan. May mga kasing mga mas malalim pa kasi mga concept sa mga problem. Hindi lang basta yung formula, hindi lang basta yung solution. Okay? Yan. Sabi nga ng Anonymous is that yung problem syempre hindi yung solution yung kailangan mong makuha sa problem, but the skill in solving the problem. Okay? So yan lang yun. Next is yung problem number 4. Ayan. Okay guys, ito lang, tip lang. Since malapit na yung face-to-face, sanayin nyo na yung sarili nyo na hindi lang kinokopya yung solution sa solution manual or anything. Kasi nga, pag face-to-face, kahit memorize mo pa yung solution manual, pag tinatnan ka ng kaba, makakalimutan mo at makakalimutan mo yung solution. So advice lang, ang i-memorize nyo is yung concept mismo. Para pag lumihis yung solution nyo, is that maalala nyo yung concept, pabalik. Okay? Yun yung magga-guide sa mga solution nyo later on. Yan, kasi mag-face to face na. So I know most of you, okay? Not all, no? Siyempre, may mga nag-study pa rin. But most of you has their own solution manuals from the higher years. Siyempre, from your ate at kuya. But as your teacher naman, no? Make sure that you also understand it. Kahit konti lang. Kasi nga, it would spark, parang spark a knowledge on you para to go deeper on what you would want to understand on the topic. Okay. So let's have our problem number 4. So a coil consists of 2,000 thirds of copper wire having a cross-sectional area of 0.8. Okay. So millimeter square. Okay, millimeter square. So 0.8 millimeter square, and the mean length per turn is 80 centimeter, and the resistivity of copper is 0.02 microohmmeter. Ayan. So find the resistance of the coil and power absorbed by the coil when connected across 110 volts DC supply. So ayan, ano ba itong sinasabi niyang coil? Pag nakakita kayo ng radyo, o yung mga lumang radyo, pag nag-NC2 kayo ng high school kayo, parang ganun yung example nito. So yung coil daw is that 2,000 turns. So na-turn daw yung coil natin na ganito, which is consists of 2,000 turns. So pag nag-shift sana kayo ng EE guys, makikita nyo itong turns na sinasabi ko kasi kayo mismo magta-turn nito pag gagawa kayo ng transformer. Minsan nga lalagpas pa kayo ng 10,000 turns para lang makuha yung voltage na gusto nyo. Okay? Pero hindi biro mag-turn ng isang coil. Mahirap. Kasi nga, pag sa gitna niyan is that, let's say, naputol, uulitin mo yan ng buo. Kasi pag sinulda mo, pangit. Okay? So yan. So a coil consists of 2,000 turn. Ano ba yung gusto niyang kunin? Yung resistance. Okay, ano to yung resistance ng buong coil na to? Ano daw yung R niya? So ano ba yung mga meron tayo na parameter? So R is equal to rho L over A. May rho ba tayo? So meron tayong rho. It was initiated in the problem. It is equal to 0.02. So my rho was initiated as 0.02 microohm meter. Next, we have our mean length. Mean length, ibig sabihin yung length sa gitna. Pag sinabi ko kasing mean, ibig sabihin pag ito yung cross section mo, ito yung tinutukoy niya, yung nasa gitna. Okay? So yung mean length per turn is 80 centimeter. So mean length per turn is equal to, so length natin, no? 80 centimeter. So 80 centimeter multiplied by meter all over 100 centimeter per turn. So per turn. Meron tayong 2,000 turns, di ba? 2,000 turns. Ibigyan kayo ng hit ng problem kahit gaano pa ka dada yung problem natin. So we have 80 multiplied by 1 all over 100 multiplied by my 2,000 turns. Okay? So from that, I will have a value of 1.6 times 10 raised to 3 meter. Okay? Next, meron tayong length. Meron tayong P. Of course, meron din tayong ito, cross-sectional area. So, hindi na tayo pinahirapan ng problem. So, area is equal to 0.8 millimeter square. Ngayon, solve natin siya. So, we have, so dito ko na lang ilagay, no? R is equal to my rho, which is equal to 0.02 multiplied by 10 raised to micro, nasa negative 6. So, ohm meter multiplied by my length, which is equal to 1.6 multiplied by 10 raised to 3 meter divided by my area, which is equal to 0.8 multiplied by 1 times 10 raised to negative 3 square. Yan. So pag ganito gawin nyo, pag hindi nyo pa masyadong gamay yung formula, ilagay-lagay nyo lang muna yung mga yung mga units natin. So i-calculate ko lang. No? And then, para later on, yun kasi yung isa sa triggering part ng memory nyo at yung tinatawag nating muscle memory ng kamay nyo. Okay? So 1.6 divided by 0.8 multiplied by 1 times 10 raised to negative 3 square. Okay. So we'll have a value equal to 40 ohm. Okay. So yan yung resistance natin. And then, tinatanong niya is that, ano daw yung power absorbed natin? Ano yung power absorbed natin when connected across sa 110 volts? So, paano ba natin i-drawing yan? So, ngayon, itong coil na to, kinonvert na natin ito sa resistance. So, take note, meron tayong 110 volts daw dyan. To-convert ko na sa resistance, so 110 volts. Take note na yung 110 natin, nakaparallel yung R natin, neglected yung voltage drop. So, therefore, we have this value, 40 ohm. Okay? So, using Ohm's law, okay, take note that this is in parallel. So, therefore, yung voltage natin dito is also equal to 110 volts. Okay? So, from that, power is equal to IV. No? But, since I have my voltage and I have no current, so therefore, power is equal to, so V is equal to R muna. So, V is equal to, I is equal to V over R. So, from that, I will have a value equal to, so substitute ko sa value ng I ko, so V over R multiplied by V. So, therefore, I will have a value equal to V squared over R, which will be equal to, ito, substitute lang natin yung 110 square all over 40. So, ano yung magiging yield dito? 110 squared divided by 40. Okay. So, meron tayong value ng 40 ohms. 302.5 watts. So, power is equal to 302.5 watts. Yan. So, inuulit ko yung ginamit nating formula, R is equal to rho L over A. So, after that formula, nung nakuha natin yung R, is that kinuha natin yung power which is equal to IV. And then, since wala tayong I, ang ginawa natin, nag-ohms law tayo which is equal to V equals IR, wherein I is equal to V over R, and then, nag-substitute na lang tayo, V squared over R. Okay, so ganun lang. Ganun lang, guys. Puro direct substitution, konti lang yung analysis. Okay, so wala pang masyadong analysis. No? Next, ito. Ito kailangan na natin ng medyo ng konting analysis. So, an aluminum wire is 7.5 meter long. 7.5 meter long daw. Okay, connected in parallel with a copper wire which is 6 meter long. So, pag gusto natin i-visualize, so basahin ko muna. So, when a current of 5 ampere is passed through the combination, it is found that the current in the aluminum wire is 3 ampere. So, yun daw yung pumunta sa aluminum. The diameter of aluminum wire is 1 millimeter. Determine the diameter of the copper wire. If the resistivity of copper is 0.017 microohmmeter, the aluminum is 0.028 microohmmeter. Okay. Para mechanics lang din, pag hindi mo maintindihan, drawing natin. So first, ito yung aluminum natin. Tapos second, ito yung ating copper. Okay. And this is 7.5 meter according to the problem. And this is yung 6 meter according to the problem. So ang ginawa natin is that, syempre, nakaparel. Naka-parallel guys, di ba? Ganyan yung parallel combination natin. Then of course from this, papunta sa ating voltage. V total. Di ba? Ganyan yung illustration natin kanina. Ayan. But take note, additive ang current. Ito yung node natin. So according to the problem, may pumasok daw dito na 5 ampere. Tapos, si aluminum, nakakuha siya ng 3 ampere. Okay? So as I have said, I total in parallel is that I total is equal to I1 plus I2 and so on and so forth, since dalawa lang, I1 and I2. If I would say that my I1 be equal to my I aluminum and my I2 be equal to my I copper, so therefore, I may say that I total is equal to I aluminum plus I copper. Huwag to, pangit. So I total is equal to I aluminum plus I copper, wherein I aluminum is equal to 3 ampere and my I total is equal to 5 ampere. So 5 ampere is equal to 3 ampere plus my I copper. So from this situation, I may say that my I copper is equal to 5 less 3 is equal to 2 ampere. That is from characteristic of a parallel combination additive. So meron na tayong signal. Ang tinatanong niya pala is yung diameter ng copper natin. Next, ano pa ba yung pwede natin makuha? Naka-parallel combination. Anong property ng parallel combination natin? Yung V total natin, syempre, equal yan sa V copper natin, equal din sa ating V aluminum. Yan yung property natin. Ano pa ba? May given na resistivity ng copper at aluminum. So therefore, pwede natin kunin yung R, which is equal to rho L over A. So ano yung rho natin ng aluminum? So rho of aluminum is equal to 0.028 microohm meter. Tapos yung length natin ng aluminum is equal to 7.5 meter. Tapos, may cross-sectional area tayo dito, di ba? Which was initiated as, may diameter, 1 millimeter. So, diameter yung given, so we'll have a value equal to 1 multiplied by 10 raised to negative 3 square multiplied by pi over 4 from pi d squared all over 4. Okay? So, pwede natin makuha yung R, di ba? So, from that, my R is equal to rho, which is equal to 0. Medyo ko na naman to. So, yung R ko is equal to 0.028 multiplied by 10 raised to negative 6. So, hindi ko na muna ilalagay itong mga to, no? Kasi meron naman na. So, multiplied by my L, which is equal to 7.5 meter. Divided by my 1 multiplied by 10 raised to negative 3 square by pi over 4. Makukuha natin yung R natin. Ito yung gamitin kong R para makita nyo kung paano mag-store. Okay? So another thing naman, no? Mas maganda la pa pag alam nyo itong calculator nyo, alam nyo mag-store, ganyan. Okay? para pag face-to-face, at least, advantage. So, 0.028 multiplied by 10 raised to negative 6. So, yan. Okay, multiplied by 7.5 meter divided by 1 times 10 raised to negative 3 square. So, 1 times 10 raised to negative 3 squared multiplied by 5 over 4. Here, 5 over 4 equals. So, ito yung resistance natin. Aluminum rho L over A 0.028 multiplied by 7.5 rho L over A, which is yung area, yung aluminum natin is 1 times 10 raised to negative 3 pi d square over 4 to. Okay? Yeah. So, ang gagawin ko, shift store tayo. So, shift store at A. So, yan, nag-store ako sa A. That is my resistance, 0.26. Oh. Yan. Yan yung resistance natin. Okay? Next, ano pa ba yung meron? V. So, may resistance tayo ng aluminum. So, next na gagawin natin, syempre, is kukunin yung resistance ng copper. Pero wala tayong cross-sectional area. Diba? Yun yung wala. So, ngayon, ang gagawin natin, nilalagay natin yung, itatabulate natin yung mga value ng copper, 0.017 times 10 raised to negative 6 multiplied by yung length ng copper which is 6 meter all over yung area ng copper which is unknown. Ang tinatanong is yung diameter ng copper. Therefore, ang ilalagay natin dito is pi over 4 multiplied by d square which is unknown. So, paano ba natin isosolve to? Balik tayo dito sa concept na to. VCU is equal to VAL. So, ano ba yung VAL natin? So, VAL natin is equal to syempre IR. IAL, RAL. Wherein, yung IAL natin was initiated as 3 ampere. So, 3 ampere to multiplied by yung RCU natin which is equal to 0.267 ohm. Which is equal to dito tayo. So, AC. Okay, so alpha A multiplied by 3. Okay? So, equals 0.82 shift store at B. Shift store at B. Okay? Ayan. Sagot natin kanina is 0.802. 0.802. This is at B. This is at A. Siyempre, lagyan nyo din ng mga markers. So, ngayon, ano ba yung next na gagawin natin? So, take note that V is equal to AL is equal to VCU. Eh, meron na tayong VAL. So, ang next na gagawin ko is that VAL is equal to my VCU. Ano yung VAL ko? This is equal to 0.802 which is equal to my VCU. Ano yung VCU ko? Siyempre, yung VCU ko is equal to RCU multiplied by RCU. I have initiated my ICU kanina, which is equal to ito, 2 ampere. So 2 ampere multiplied by my RCU. So ano yung RCU ko? Ito yung unknown. Pero, in-initiate ko kanina that this is equal to 0.017 multiplied by 10 raised to negative 6 multiplied by yung length natin all over pi over 4 multiplied by d square. May dalawa kayong option dito. Pwede kayong mag-shift solve or pwede kayong recta. Pwedeng gawin nyo, d is equal to, syempre, d square. Pagawan ko ng square root. So, 2 multiplied by 0.017 multiplied by 10 raised to negative 6 multiplied by 6 all over pi over 4 multiplied by 0.802. Yeah, so yan. So, square root. So, easy para hindi nyo na isulat mamaya yan. So, square root na lang. Okay? Square root of 2 multiplied by yung current to multiplied by yung ating 0.017 multiplied by 10 raised to negative 6. 0.017 multiplied by 10 raised to negative 6 multiplied by, syempre yung 6 natin which is the length, multiplied by 6. So yan. Divided by pi over 4. Shift pi over 4 multiplied by alpha b. Kung in doubt kayo sa naka-store sa value nyo, mag-calc kayo para ipakita yung value ng b nyo. Set is equal to 0.005. So, SD natin. Okay, so ing tayo para mapakita yung ating engineering term na sa 569.04 micrometer. Okay? So yan. 569.04 micrometer. That is our diameter. Recap ng solution. First, kinuha natin, drawing natin siya, and then, para malaman natin kung anong property yung gagamitin natin, series or parallel. So, from here, kinuha natin yung property ng parallel connection kasi nga sinabi sa problem that it is in parallel connection. Next is that, from the property ng ating parallel combination is that yung current natin is additive, and then of course, yung voltage natin is always equal. Okay? So from that, we solve the problem. Ito yung pinaka-pillar natin dito. I total is equal to I1 plus I2, which we solved na yung value ng current ng copper na pumapasok sa kanya is 2 ampere. And then next pillar, next equation is ito. Yung property ng parallel is that kung ano yung voltahe na pumapasok dito, since naka-parallel siya dito, equal din siya sa voltahe na pumapasok dito. Okay? Kaya sinabi natin that VT is equal to VCU is equal to VAL. Ngayon, kinonsider natin itong property na to. So after that, kinalikot natin yung problem sa aluminum since ito yung kompleto yung given. So ang kinuha natin doon is syempre yung resistance natin which is R equals rho L over A. Okay, R is equal to rho L over A, and then upon applying that one, nakuha natin yung resistance natin which is equal to 0.267 ohm. Pinakita ko paano mag-store sa A. So take note, pag mag-store kayo, kailangan nyo ng marka. Markaan nyo para hindi kayo mataranta. Pangalawa is that after solving for my RA, pwede ko nang kunin yung aking voltage sa aluminum. Kasi nga meron na akong I aluminum at R at my aluminum. So since voltage is equal to IR from Ohm's law, so therefore nakuha natin yung value ng voltage natin which is equal to 0.802 volts. Ito. Yung voltahe dito, so kumbaga, so pag ginawa ko yung circuit nito, ganito siya, tapos ganito siya. Okay? So yan. So ito yung aluminum natin, ito yung copper natin. So, yung voltahe ng copper natin, ng aluminum natin, is same as the voltahe ng copper natin because they are connected in parallel. So upon using that property, I can solve for the value of my copper which is equal to 0.802 which is also equal to my aluminum. Okay? So since equal sila, dito tayo nag-base sa sumunod. Kinuha natin yung RCU natin by our formula. From that RCU, no, linagay lang natin yung mga nandito na dati, katulad ng row, which was initiated here, yung ating length, which was 6 meter, yung ating row, length, yung diameter unknown. But alam natin yung current na pumapasok sa kanya, which was initiated, which is na 2 ampere. So from that, inequal natin sila para ma-solve yung diameter natin. Okay? So yun yung solution. So concept na parallel connection and also yung ating Ohm's law. Yun yung mga key concepts natin dito. Okay? So yan, that is problem number 5. Okay, meron pa tayong natitirang 4 na problem. But probably try to solve this one. No? Kasi binigay ko sa quiz to. Hindi ko lang alam kung sinolve nila yung mga problem set na binigay ko. So, meron sa quiz to mga to. Quiz nila. Quiz nila. So, kung siguro may klase kayo mamaya ng alas 6, no? So, assignment nyo na lang to. Okay? Set. So, take note that itong mga to, no, nasa konyo na to, na-upload na sa LMS nyo. Itong problem 6, 7, 8, 9, baka lumabas sa quiz nyo. Para pang-check ko lang kung sinasolve nyo wala pa yung mga hindi na-solve ng problem. Okay? But take note, yung mga concept parehas lang. Right? Okay. So, if you have any question and query about the different examples, pag sinolve nyo sila later on, feel free to ask me kung ano yung solution or kung paano i-solve. Okay? So, I would give you a picture of that solution. So, isa-solve ko manually. So, thank you guys for attending my class. But if you wish to continue our discussion, okay lang sa akin, no? But if you would not, okay, you may now leave our room. Okay? So, thank you and good day, guys.
Hi, sir.
Thank you po,
Thank you, sir.
Hi, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.